Hi guys, welcome to today's tutorial. We're going to look at some level 2 chemistry today. This particular video is going to focus on comparing the pH and electrical conductivity and reactivity between different strength of acids and bases as well as salts. I've gone through 2018 and 2019 exams on my YouTube channel, so you can check out all of those in the old exams. Just find the playlist and go through the old exams. You can definitely do that. This is from the 2017 exam, because this type of question is best explained if I actually show you what a question would look like, and then you can see where we're going with this. Okay, so as you can see, we have a table showing the pH of the 3 acidic solutions. So these things are all acidic, so they're giving you 3 acidic solutions: ammonium chloride, which is NH4Cl, propanoic acid, and hydrochloric acid. So in this case, it gave you 3 acids. So in this case, we can just focus on this question, and I'll do a little bit extra towards the end. So they gave you equal concentrations. So the concentrations are the same. Now, what you can, because we haven't done the calculation bit yet, in year 12, if you know the concentration of a strong acid, you can actually calculate the pH, and after that video you're going to know the pH is going to equal to 1. Now, when the pH, to use the concentration to figure out the other pHs, that's year 13. The syllabus is in year 13, so you can actually do that as well. All right, but that's next year. But they gave you the concentration, they gave you the pH, and as you can see, HCl in this particular example is clearly a strong acid because it completely dissociated, because you have equal concentrations of 0.1, 0.1, 0.1, but then HCl gives you the lowest pH. So if HCl gives you the lowest pH, it must be the strongest acid. So C2H5COH, the guy in the middle, has the moderately high pH, so that's the second strongest acid, and then NH4Cl is the weakest acid compared to the 3. Now, why each of them have the same concentration but different pH? Because that's to do with the level of dissociation. This is due to different degree. Oh my god, I can't spell different degree of dissociation. Okay, so what that means is that if you have HCl is a strong acid, so that means it's going to completely dissociate in water. It's going to give all of the H's to the H2O, so you're going to form H3O plus and Cl minus. So this single arrow means this is completely dissociated, and that means at the end you don't have any of these anymore. You have lots of H3O plus ions. Okay, so there's going to be, so this is, if I just bullet point this, you can look it up on the NCEA website for some, for the proper mod answers. But like I mentioned numerous times, if you were just to look for answers, that's not what you're here for. You're here for the explanation. Okay, so this is complete dissociation. So complete dissociation means that you're going to have very high concentration of H3O plus. It's going to be very high, and that means you're going to have a very low pH. Okay, because it's completely dissociated, you're going to make lots and lots of hydronium ion. The higher the concentration of hydronium ion, the lower the pH. Okay, so if you look at C2H5COOH, this is a weak acid. Okay, so that's going to add water, and this is going to partially dissociate. So make sure when you do partial dissociation, to do the double arrow. You're going to make CO minus plus H3O plus. Okay, so this is only partial dissociation. It's only about 1 to 5% of the weak acid is going to dissociate. So this is partial dissociation, which means low concentration of hydronium ion, and that means hence you have a relatively high pH compared to that one. Okay, now if you look at NH4Cl is probably the hardest one out of the 3. NH4Cl is what we call a salt solution, or just a salt. So what that means is that this is 2 steps. You have to have the NH4Cl. You have to first dissolve it into water first. So you put it in water, it's going to dissolve, it's going to become NH4 plus aqueous and Cl minus aqueous. Okay, and then your NH4 plus, which is the conjugate acid of NH3, this is going to partially dissociate, gives one of the H's to the H2O, so it becomes NH3 plus H3O plus. Okay, so this is two steps of equation. The first part is dissolving, so that's just when you have the solid salt dissolving, and this one is that once they have dissolved, the NH4 plus will further dissociate with the water molecules to form a very low concentration of NH3 and H3O minus, H3O plus. Okay, so this is partial dissociation. And then you can say very low H3O plus concentration as a result produced, and therefore you have a very high pH. Okay, you can get questions like this for different types. Like let me give you some example. Like say for sodium hydroxide, this is a strong base. So that means this will completely dissociate into Na plus and OH minus, and then you have lots of, so you have high concentration of OH minus, which means you're going to have a high pH because you have a strong base. If you have something like NH3, this is a weak base. As you can see, this is not answering, this is not the question anymore. This is going to go a little bit beyond because they only ask about acids, but we can do better. We can talk about the bases as well. Now the reason being is that you may go, how am I supposed to know if I have NH4Cl that the NH4 plus is going to turn into NH3? Well, that's probably the only two that you are going to get in the exam, because they can't expect you to know anything else, because you're only year 12. Even as year 13s, we don't really, well, we can't expect you to know everything, so they tend to stick with the really easy ones. So just be very, very careful when you see NH3 and NH4 plus. That's why I keep throwing them out here, so you can become very familiar with them. Okay, now if I pick a salt solution, before we do the last question, if I have CH3COONA, so this is a salt solution. So this is going to, first of all, it's going to dissolve into CH3COO minus plus Na plus, and then you're going to be like, hold on a sec, I've seen this guy before, because if you put this guy with water, because once it has dissolved, it's going to partially dissociate. It's going to make CH3COOH and OH minus. So okay, so this is your strong acids, weak acids, and then the different types of salt. That's all included in this particular section. So when you're talking about this particular type of question, sometimes they give you the pHs like we see in the table. Sometimes they give you 3 pHs and ask you to assign, and that in that case they won't give you, like say, I wouldn't expect you, which is really unfair, to know that the NH4Cl is a weak acid compared to C2H5COH. Like that's just not realistic. They can't expect you to know that. So if they ask you to assign, they give you 3 or 4 pHs, and then they give you 3 or 4 solutions. Normally one is a strong acid, one's a strong base, one is a weak acid, maybe one's a weak base, maybe something that's neutral, and then you just put them in the middle, and you can just assign them using the same reason that we just talked about before. Okay, now just think here, so that's to do with pH. So just remember, pH is about the level of dissociation. The higher the dissociation of the acid, the more hydronium ion you produce. The more hydronium ion you produce, the stronger the acid, the lower the pH. Vice versa, if you have a base that's dissociating, if it completely dissociate, you make tons and tons of hydroxyl ions, which means the higher the pH. Vice versa, if you partially dissociate, you make a small amount of hydroxyl ions, which are the the OH minus ions, the lower the pH, okay, because it's not as strong on the pH scale. Okay, now this is the second part. Why the solution of NH4Cl is a good conductor of electricity, and C2H5COH is a poor conductor electricity. So remember, electrical conductivity depends, this depends on the concentration of free moving ions or electrons. This is going back to 2.4 in the solid section. So why does something conduct electricity? Because it either have one of these two things. It either has free moving ions or free moving electrons. So why does NH4Cl conduct electricity even though it's a really weak acid? Like say if you go up to here, you look at the pHs, you look at one is 5.62, one is 3.44, and you may go, how does that become a really good conductor? And this is where, if you can do the equations, this is where it's going to pay off, because this is two parts of the equation. It's two parts. This is the first part, and then the weak acid further dissociate partially to give you this, guys. Now you need to remember the NH4Cl. The NH4Cl will completely dissolve and form high concentration of NH4 plus and Cl minus. Now these things here, as you can see from their charges, these two species are free moving because they're dissolved in the liquid, and then they can go wherever they want. Okay, so if you have high concentration of free moving ions, that means electrical conductivity. Okay, so you make the second equation doesn't even matter here. Yes, it partially dissociate, but what difference does that make? It doesn't make any difference. The first process of dissolving, which is step number 1, is already producing tons and tons of free moving ions, and the thing can dissolve really easily. Now if you look at C2H5COOH, if you look at this guy that's dissolving, well, does it dissolve, sorry, if you look at this partially dissociating, it's going to give you this. Okay, now we don't have, this is only one step of dissociation. Can you see, like I keep mentioning, using the mathematical numbers to remind you, like say if I had 100 molecules of this, only one of it will dissociate into that, and then you have 99 of that sitting here. So you can see that you're only producing a very percentage of these ions. Okay, so because this is a partial dissociation, which means the concentration of C2H5COO minus and H3O plus is very low. Okay, so if these concentrations are very low, then they have very little free moving ions. If they have very few free moving ions, they have horrible electrical conductor, because the bulk of the solution is still going to be C2H5COH, and that's not an ion. And I keep saying, even some of my year 13s, in the past, struggle with the idea of ions. How do you know if something is an ion? Just look on the top right hand side corner. If it has a plus or negative sign, that means it's an ion. If it doesn't, it's not an ion. Simple as that. Okay, now I do want to quickly, this is the same question, I do quickly want to talk about, in terms of which is not on here, but I do want to talk about reactivity. I'm just going to use these two, HCl and C2H5COH. I'm just going to give you as an example. All right, so if we compare the reactivity of these two acids, okay, so the concentration is still the same. This is 0.1 moles per liter. This is 0.1 moles per liter. So that there is exactly the same number of ions in the solution. I say there's 10 moles of each. All right. So you should be able to figure out this. Yeah, if I have 10 mils of that, 0.1 mil, 0.1 mole per liter, 0.1 mole per liter, the number of moles of HCl is going to be the same as the number of moles of C2H5COOH. Because how do we do that? You just use N equals CV, and you can see it's going to be the same number. But however, these two species, these two acidic solutions are going to have a different rates in reaction. And how does that work is that HCl is going to have a much higher in terms of the rates of reaction. HCl is going to be much faster compared to C2H5COH, even though the amount is exactly the same. But this is where you are going to, this is why we learned everything before acids and bases. So if you have some zinc, if you chuck some zinc into HCl, and then you chuck the same amount of zinc, same surface area, same everything into the same concentration, same moles per liter of C2H5COOH, and then if you look at the rate of the reaction, the HCl is going to be much, much faster. Now, why is that? Why is that? This is because you're going to see this equation again. I'm just going to keep bombarding you with these equations because hopefully you're going to remember them. Now, why does HCl react faster? Is because HCl completely dissociate, because it's a strong acid. It completely dissociates and produces a high concentration of H3O plus ions. Now, these H3O plus ions are readily available to collide. And then you can talk about the stuff you learned in the rates reaction, because there are more ions, more of these ions readily available to collide, so the frequency of successful collision will increase. Okay, so they will finish reacting very quickly, and yeah, because the ions are already sitting there, they're just like, yep, let's react, let's go. Okay, now in comparison, if you look at C2H5COOH, this is going to partially dissociate, and this is going to make C2H5COO minus and H3O plus. And now remember, it's the H3O plus that does the work, you know. So when we look at acids and bases reaction, acid plus metal, it is always the acid that does the work. And what do acids all have is that the acids have H3O plus concentrations. Okay, so it's not the C2H5CO minus. We don't really care about that. Now, because this is a partial dissociation, that means there's very low concentration of H3O plus ions. Okay, so what's going to happen is that these H3O plus ions will react away. You know, through colliding with the other zinc metals, for example, they will react slower because there's, you know, not as many of them sitting in the same volume, because it, you know, just less of them at the beginning. Will react slower, so, you know, less ions available, for example. So therefore it's harder for them to collide with the other reactants. So, you know, they'll react slower because there are less ions available, just simply lower probability of them hitting with each other. Now, once they have reacted, once H3O plus has reacted, the system is no longer at equilibrium. And you can see, if you're not so good at this part, you need to go back to Le Chatelier's principal videos and rewatch those. So the system is no longer equilibrium because your H3O plus is gone. So the ratio of the products divided by the reactants, which is your Kc, is no longer the same. So what does the system do? It's going to shift to the right. It will shift to the right to make more H3O plus ions. And then this H3O plus, so you just be on a cycle. So what it does is that you have a small amount that dissociate, they will react, and then the system not at equilibrium, you'll shift to the right to make more H3O plus ions, and then they will react away, and then you keep shifting to the right, so eventually, which will take a very long period of time, that's why they're horrible in terms of the rates of reaction, eventually they will stop reacting. You know, after this continuous cycle, they'll stop reacting, and because they run out of solution. So this is what I will draw in terms of the graph. Let's say this one here, the one on the bottom, is the C2H5COOH. The one on the top is going to be HCl. This is the amount of products they produced. This is the time taken for that to happen. But then I want you to realize you will they'll stop, they become flat around, you know, around the same amount of products produced. They'll stop at the same point because they produced same amount of products. Why is that? Because you had the same number of moles. Okay, you had same number of moles in the thing. You have same amount of the ingredients. You're not going to magically create more products that way. One just simply happens to react faster than the other. Okay, so I hope this explanation makes sense, because normally you don't even get asked about the last 6 minutes 10 minutes I just did. You know, this type of question you rarely see it because it's a little bit harder, but it just makes so much sense. You combining everything you learn for this entire unit, for the entire achievement standard. This is why, and sometimes I don't think the curriculum does that well. It doesn't really explain to you why you're learning a lot of the stuff, and this is why hopefully it makes a little bit more sense. You need to understand the rates of reaction to understand what the heck we're just talking about, and then understand the equilibrium, and then you can once you understood equilibrium, you can understand the dissociation of weak acid and bases are an example of equilibrium, and then combining the two together, and then you learn the Chatelier's principle, and then we can fully explain why a strong acid would react faster than a weak acid. Okay, so I hope that makes sense, and we just have one more video to go, which is the pH calculation, and then after that we're done with this achievement standard. Okay, so hopefully this has been helpful. So as always, if you could like and subscribe, that would be fantastic, and any questions, drop that down in the comments, and I'll see you guys next time. Bye bye.